of Fusion Formatics, and we are an engineering firm which is specialized in design optimization for additive manufacturing. We use many different software and hardware equipment in our company, and some of them we also resell. You can see here some printers and also some software. If you go to the next slide, we can see our vision in a nutshell. So again, we are specialized in optimization for additive manufacturing, and also especially for lightweight parts. Also this for low volume production, not just for prototypes or for a proof of concepts, really going into manufacturing, and also for functional assemblies. So we have the focus on really on high complex parts. We optimize, and we go many times into lightweight parts. We put several parts as an assembly together and can print them as an assembly, so we have functional assemblies, and at the same time we can embed in the prints already electronics. So our services, at first the design optimization. We do of course also research and development jobs, make prototypes, or also a pilot. So we make a pilot and we can figure out for you what the best way is to print the design optimization, and we can sell you in that case the way how we did it, inclusive the software or the hardware that we use. We have also print farms, a couple of printers where we can print just several parts in a mount, so it's still cheaper than with injection molding. You can imagine if you print 24 hours on 20 printers, that we come there in a good area from ROI, and hardware and software sales is the reselling part. We are mainly in aerospace, defense, and also in the automotive tool and die. Couple customers also in the dental and medical industry, and it goes further. Of course, we use some nice software like Evolve from Inspire, where you go into product and industrial design combined with functional design and additive manufacturing. If we go onto the print farm, sometimes we have there a couple jobs just to print hundreds or thousands of easier parts on the print farm for the entertainment and Hollywood area. And machine manufacturers, we can see here, we do a lot also on our print farm, since there are a couple parts in the machines. When a company doesn't produce more than 10 or 15,000 a year, it's just a very convenience to have still parts. They're very competitive, let's say to the 1,000 or 10,000 parts printed with FDM, anytime open for innovation and changing the part, instead of spending the time and the money for tools for injection molding, and then you have to stick with that as long as it's not amortized. So we go lightweight, and that's in different areas. We make holocausts or lattice structures inside of the parts, or we really change the design, and with that we can go into composite printer, what we see later on the software for Mark 1 or the Markforged Mark 1 printer. We have FDM printers, and we have a couple of metal printers to go here more in this area. Weight reduction, that's clear. Companies looking for bionic structures more and more. That's clear. Also a lightweight actually goes towards the internal cavities and lattice structure. We are interested in very complex parts to optimize them for additive manufacturing, and of course it makes also sense, especially for spare parts, to have there not always anything on storage, that we just go ahead and print them if needed. In the medical area, we also here with PEEK and titanium and different materials. Here we can see the functional parts that we can print several parts in one piece, or here embedded electronics into the Mark 1 printer. So we also resell and we use scanners, but also for design optimization we use Netfabb 3S, and from Solid Thinking Inspire. Scanning we go into Polyworks and SolidWorks. Additive manufacturing, we have composite, we have FDM, we have object, we have of course the metal printers, and then we have different finishing tools, and also we go into inspection and quality control, even up to vibration measurement. And another one is our augmented reality. We have equipment that we have here, 4 projectors actually around, so you're never standing in your own shade, and we can project here the virtual reality onto, or the virtual picture here into the reality, in that case a car. This is a part or a technique that we use also when there is assembly street. They have often changes, and here in that case the employees, they're getting here nice instructions what they have to do next step, and if it combines with maybe a printer tool on the Mark I printer with an RFID chip, the software can already recognize what tools is right now is used, and then the instruction for that. So this is Fusion Formatics as a small overview, and it's clear that the main benefit in additive manufacturing is really that we can produce parts that's not possible right now in any other traditional manufacturing process, and this brings us to the focus, to the vision, and to the main benefits of Fusion Formatics as design optimization for additive manufacturing, and especially for lightweight parts in plastic, metal, and composites. You can see here the interface of the Eiger software, which is the slicing software, and where we can influence the fiber on the Mark I printer from the company Markforged. And I want to present you here a little bit how you can go through the software, which is really straightforward and easy to use software. You can see here is a part, has also some thin walls, and we want to see how we get their fiber in, and this is how it's on the print bed. Print time 2.5 hours, and we can see here on the right hand side is are the buttons actually where we can go straight through. So the first one, do you want to use fiber? So you can choose which fiber you want to have and just start from there, and you can say also what pattern you would like to have, concentric, or you want to just make it more, this is close or the same than isotropic. The full makes it just really completely full with fiber, as much in each region as you go in. It keeps the same angle. The isotropic, we can see we can change the angle, and what that means, change the angle, you can see if I go into the internal view in a couple seconds. I go here a little bit further to the advanced settings. You can also make here a choice, or if you want to use support, this is very nice also to have here the option to say no, I don't want to use support, and we change and we optimize the design for itself for additive manufacturing, where Fusion Formatics is specialized in. And then you can have a couple surfaces where you don't have the supports and less post-processing. We can also use a feature with thin thin features. This helps in this case. I chose it here because we have here some thin features. Just change the pattern and the print speed also in that way. We can use here a preem. This is good if you have the contact are just on a few points on the print bed. We have here enough surface from the part, so we don't need this. In case you come with an STL file from an Imperial system, you can of course change it there to Imperial, and then it goes further. How we want to fill it with nylon, we can fill it with a honeycomb, hexagonal, rectangular, or triangular. So this is the first, the shape for the pattern inside, and then we can choose how much the density is. We can make it very light, and that means here the triangulars in this case will be very big. Or we go here and the fill density very high, or we make it even 4. So the triangles, they go smaller and smaller, so it fits more nylon in. This is nice if you have a part you don't want to use necessarily any fiber. You can make a very stiff part just pure with nylon, so you can make it full. And if you use also walls, we can see here 2 walls at the edge. You can imagine if you put it up to 4, that makes it for itself very stiff. In case I want to put fiber in, I want to make it light but also stiff, I will make the density down. And also the walls, it really depends on 1 or 2. The point is that I want to have here not so much walls, I want to have more space in between to put the fiber in. So this is how I go straight forward. You just make these choices, top to down, you go and save, and the software slices it and go through and calculates it for you. If you go to the internal view here, we shift in another version of Eiger, and we have here also a 3D and a 2D view. In the 3D view, we can now see I chose there to pack the whole part full with fiber, and we can here nicely see there is in any area here really we get in the fiber, and this is packed with, in this case, Kevlar. Maybe I would not choose Kevlar for this, but since it's yellow also on the software, it's really nice to see where the fiber goes in. So here we can see in every part, if you go a little bit in a way to show you here the walls. So here you can see I could even make here less walls, but I think 2 are fine. We still got fiber in, and then I show here the fiber, how we have that set. So this is already automatic calculated. I want to show you this with a part which is not filled yet. It's pure nylon. You can see again the triangles, and can change here also a little bit the view, so you can go through. Okay, here you have the walls, and then that would be the triangles, and we will see how we make that manual more interesting with some fiber. I'm in the 3D view, and I can just choose any region here to make fiber in, and we can see it visually. Let's say go from here to here. There's also the surface, so it would be interesting to have from the bottom part, from the surface, and from the top part, to see how we get the fiber in. And I just will choose here fiber. I use isotropic, which I like, we'll see, but I want to shift the fiber angle from layer to layer. So just use first layer 180, and then 135, 90, 45, and 0. And this doesn't have to be exactly these numbers. Sometimes I go through and I see that I get with a 0-degree angle fiber in a part I like, or maybe even sometimes it's 1 degree. It really depends, and you will see that when we go on apply for the changes. Now we can see on the bottom in this bar, the software calculates through where it gets the fiber in. We see also here with this graphic how much fiber it gets in. This is obviously here where we have the surface on top, and there we get in. And now I want to see if we get in each region fiber, and yes, we got in each region fiber. That's very good. We make here a better view. I just want to have the isotropics. I can see that at this point here is maybe a little bit less. Of course, could also just be we go a little bit higher and we have more, but I showed you this in the 2D view. We have here fiber 180, and now we go with 135, so the angle changes, and with that way we get the fiber in different areas, and also with a change from the angle it makes it just more stiff. This is from layer to layer, so we get in each areas here the fiber, and that was the top view that we saw. Really we got in each area. So now here we got nothing in, but the software will make automatically here a very thin and layer with nylon, so not the triangle pattern, it uses here also the isotropic pattern. And if you go here forward, now we have the 45, and we get here nicely fiber in, so you can see how we get here in each area. Now we go a little bit more to the end, it changes here, we come really in each area, and I want to show you here. I want to have just here a couple layers now with fiber here in this area. Use here 90, and then we go one forward, choose here again, and I choose here also 90 to get here slowly in. And now we go in one, and we use the pattern full fiber. And now I shift a little bit the view, it's even more dark, but you can see how I get here nicely in. So I can make here also just a couple layers. I go in the 3D view, shows from here to here, use fiber, but I will say full fiber, and I say apply changes, and then you go into 2D view. You can see here how we get there in each region there. So here the right hand side is good for with fiber. Also want to quick show you, if we are in the 3D view, the concentric, making maybe here a small one, make fiber, use concentric, 30 fiber rings should be more than enough. If it's too much, it doesn't matter. If you make one concentric ring, it will just make one ring. If you make 30 but just 3 fits in, it doesn't matter. It fits in that case as much as you can. See here, again, the calculation on the bar seems like we got there a lot of fiber in. So we go to this point, the fiber goes concentric in each area, and there's a lot from it. So that's the way that you have here concentric getting in. Here we have an isotropic, changing the angle from layer to layer, and then we get in each region, make it very stiff. This is with isotropic, but if you want to have just very a lot of fiber in each region, you just use the full fiber, which makes it here really in each area. This is how you get in with different techniques here, fiber through, and you can make a decision on each layer. Going back to a full D view, maybe without a support material, and also a full view of the part. So here we can see that's how we just influence a couple layers. You can make a lot of automatic very fast through the part, and can use here just a fiber type, and you apply for it, and the software go through and makes this very fast in a way that you have not to go from layer to layer. You can really make here just a pattern and have there a part very fast in a way that you like. You can see here again, now we made the full part on top. Go in this region more here, so you can see here where we also in very thin areas we got here the fiber in. Alright, this is the presentation to the Eiger software to apart the gear casing, and this shows you a little bit straightforward but also the easy flexibility of the software.